I find this question very interesting because I think without the diagram, this could turn into a easier question. Now, what is the diagram trying to highlight is that L, the atom for L, only has one electron in its outer shell, and we can just, what's also given to us is the proton number, right? So I think the need to know thing is that it's a group 1 atom. It's in group 1. Whereas M over here is in group 6 because it has 6 electrons on its outer shell. We could just practically identify these elements right now. 3 protons means it's lithium, and 8 protons means we're talking about oxygen. So we're literally talking about lithium bonding with oxygen and finding out its MR, so to speak. Okay. Now, even if you don't want to go there, the question is kind of straightforward. These two atoms combine to form a compound. So this is in group 1, this is in group 6, right? What are their relative valencies? So L will have a relative valency of, +1, and oxygen, or M over here, will have a valency of 2 minus, right? Oxygen. And we just cross them out, right? And we understand that it'll be L2O. Oh, so why do I keep referring it to O? L2M is the product of this compound. Like the compound has a molecular formula L2M. How do I know that? Or can I confirm looking at the periodic table? Well, if you look at the periodic table, you can compare lithium and oxygen. I guess that's fair. But I think one of the examples we keep doing is sodium and oxygen, which is Na2O, and that should ring a bell as well. Okay? Na2O. But again, this question can be done all without the periodic table. You don't really need it. You just need to understand that when they bond, using their outer shells, using their valency, you can identify how they'll bond. And they'll bond in this manner, L2M. So this compound ka MR kya hoga? Because the next part is going to moles. So it has two. So the MR for L is what? The MR for L, it has 3 protons and 4 neutrons, an MR of 7, right? And it's matching with the periodic table again. And this has an MR of 16. Well, that's again oxygen, right? Okay. So what is the MR for L2M? Well, that's going to be 2 times 7 plus 16. So 2 times 7 is 14 plus 16. I think that comes out to 30, right? So the next part is asking, what is the mass of 1 mole of this compound? Well, 1 mole of any compound will just be equal to its MR, but we can also calculate it. Moles equals to mass over MR, and you'll see mass will be equal to 1 mole times its MR, which is 30, equal to 30. So D is your answer for this set, this question number 1. This is probably one of the more difficult questions in the test. Why do I say it's difficult? Is because it's longer. It's a 2-step process. First, you have to find out the moles in C2H6, then you have to find out the moles again in propene. So a volume of ethane, C2H6 at RTP has a mass of 20 grams. So let's figure out iske moles kitne honge. So step 1, we're at like phase 1 of the part. It's a 2-step problem, right? Step 1 is find out the moles of ethane, right? So it's going to be moles equal to mass over MR. Mass is 20 and MR is 2 carbons and 6. So that's 24 plus 6, 30. So that equals to 0.66 or 2/3 moles. I'll just use a fraction because it's easier for the calculator. Take it. Step 2, I gotta find out the mass of propene, what is the mass of an equal volume of propene? So equal volume means equal moles because they're both gases, right? So the mole stays the same for this part. ठीक है? And for an equal volume or equal mole of propene, what will be the mass? Well, the mole is 2/3. Let's try to figure it out. So for propene, on the left we talked about ethane, which is C2H6. Over here we're talking about propene C3H6 again. ठीक है? And try to do this. So it's again mass over MR. Moles are 2/3. Mass is I need to find out. And MR for propene, what is it? You have 3 carbons, which is 12 times 3, which is 36, plus 6, 42. That's 42. And I try to divide this. 42 divided by 3 is what? 42 divided by 3 times 2, 28. Mass is 28 grams. That's my answer. ठीक है? 28. I think like not many got this wrong. Straightforward question. Just finding out the MR for this little crystal here. So you have 1 copper. Oops, my highlighter is still selected. You have 1 copper and a sulfur and 4 oxygens. I'll put them in a bracket with a hat so you know it's oxygen and not 0. And 5 water molecules. You know what? To make my life easier, I'll think of this as 1 compound, right? So it's going to be plus 5, H2Os. Let's do that for a bit and see if we can get a faster answer. So copper is 64 in its weight. 64 plus, I think sulfur is 32. Let me confirm. Always confirm. 32 plus 16 for oxygen plus, I know water is 18 because 16 for oxygen and 2 hydrogens, that's 18. 5 times 18. And I got to put that in the calculator. Now I think we've done this so many times in the class. I remember the answer. It's 250. ठीक है? Let's move on. All right, there are 2 ways of doing this question. All right, you can use some logic, like the lighter one of them will probably have a lighter mass. So, like it's kind of easy to do. You can rule like 0.1 mole will be equal to the MR, so the MR is going to be really high. Iska bahut hi zyada lag raha hai mujhe. 2 oxygen, this is going to be. Like you can develop an intuition and start crossing it out. But if you're completely lost, how I do it is, like I would definitely rule some of these problems out because some are clearly way larger. ठीक है? Like A is completely out. It just looks like a huge molecule. Yeah, it's really huge, and even 0.1 moles of that. Oh, it's 0.1 moles of it. Okay, maybe I need to consider it again. ठीक है? So here's how I do it. I do it right in front of it, but I don't have room, so I'll rewrite it. So we're talking about A, B, C, and D, right? What are the moles being talked about for each of these? 0.1, 0.5, 0.5, and 1. What MR? I again do it right in front because I don't have, it's too small. I'm doing it, writing it down. So I wrote down the moles. Now I want to highlight all the MRs. Silicon is 30, no. Silicon is 28. That's 28 plus 32 for silicon. That's 60. Let me change my color as well. That's 60. The MR is 60. Oxygen is 32. Lithium is what? Is lithium 7. And ammonia is 17, if I'm not too off. ठीक है. Now what are we doing here? These are the moles. This is the MR. I want to figure out the masses for each. Now mass is mole times MR. So it's each value on the left hand side multiplied by the right hand. Just multiply these values. So I can just do some of these orally, like right there. I think 6 for the first one. Why is it not writing? 6 grams for the first one, 16 for the second one, 3.5 for the third one, and 17. I don't even have to use a calculator for these. Okay. And the least mass is C. Okay. C. Easy, straightforward. Try thinking. So there are certain ways of tackling a certain question. With practice, you'll get better at it, of course. But ये बहुत सारा data जब दे देता है ना, make a table right in front. Do it here. I would do it here. You don't have to highlight moles or MR. Just write them down and start multiplying and ta 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 ta. Like you don't have to think or debate or stress over it. Just copy it, ta 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 ta, done, and just rule it out. Questions like these, just people get confused with like I just got confused when I was starting it. Was it 0.1 or just, like I think I misread it. So huge chance of that happening when there's a lot of information going on. Just write it down like this, right in front, solve it, you're done. What is the number of moles of hydrogen atoms in 3.2 grams? Now this is where that talk comes in, where we start thinking of moles like the dozen, right? Ek darjan wali kahani. But let's figure out the moles of methane first. 3.2 grams of methane में कितना होता है moles? So methane CH4 की बात हो रही है. Yeah. So the moles are going to be it's mass over MR, right? Moles equals to mass 3.2 over its MR, which is 12 plus 4, 16. So that looks like a nice number. 3.2 divided by 16, 0.2. 0.2 moles. ठीक है. Now I gotta figure out hydrogen के atoms कितने होंगे. How many atoms are there in methane? ठीक है. मुझे methane के moles quantity पता चल गई. 0.2 moles. Let's see how to see this problem. If I have one atom of methane, it has, I'm not making a reaction over here. I'm just pointing an arrow. It has 4 hydrogen atoms. Like one car has 4 wheels in it. So if you have 10 cars, let's put that example right on top. So cars to wheel ratio, cars to wheels. If you have one car, you have 4 wheels. If you have 10 cars, you have 40 wheels. If you have 0.2 moles of a car, you'll have how many wheels? Well, 4 times 0.2. You'll have 0.8 wheels, right? 4 times 0.2. And then your answer becomes D. Ozone is O3. What is the volume of 48 grams of ozone? Well, let's find out the moles first. That's always easy. Moles of ozone are the mass of ozone divided by its MR. It's 3 oxygen. Each oxygen is 16, so I think it's going to be 48 as well. And that comes out to 1 mole. What is the volume of gas? So this question can be changed as, what is the volume of gas when it's 1 mole? What is the volume of 1 mole of gas? Well, that's easy. Well, moles is equal to volume over 24 decimeter cube, right? And so it's 1 V over 24. I mean, I wouldn't even do this. It's just 1 mole is 24 decimeter cube. La 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 la. Right? 24 dm cube. And the answer is B. Right? Let's move on. All right, a very similar question to the previous question, where we were talking, where we were trying to find out the how they would bond, like in what ratio they would bond. So X represents the element of atomic number 8. Atomic number 8 is going to be, well, oxygen. It's always oxygen. This is oxygen. and Y represents atomic number 19. Well, that's potassium. So in other words, this is group 16, this is group 1. And again, they bond in the same ratio. It's practically the same question. K2O. Why? Because oxygen has a charge of -2, like 2 minus. Potassium has a plus. The only way to balance them out is having twice the amount of potassium than oxygen. You can still do that crossing thing, right? Okay. The two elements react together to form a compound. Well, we just figured this out. So it's going to be Y2, what's the other one? X, Y2X. So what says Y2X? And Y2X, Y2X, and the other two are not Y2X. Cross that out. Okay, so the debate is between A and B. Now, potassium is a metal and oxygen is a non-metal. What sort of bonding is between a metal and a non-metal? Ionic. So, oops. We're talking about ionic here. But D is already out and B has both ticks. So the answer is B. Right? Easy. Alright, one atom of element X and two atoms of element Y react to form an ionic compound. Has to be ionic. Let's see if we can rule out a few non-ionic compounds. I don't think we can. Metal is here, non-metal is here. Let's see if they can bond in the ratio. So it's X needs to be 2, this needs to be 2, this needs to be in the ratio 1. Can calcium and chlorine do that? I think calcium and chlorine, because calcium is in group 2, chlorine is in group 17, it's going to be Ca. Let me just write it in front. It's going to be CaCl2. Calcium and oxygen are going to be CaO. For sodium and chlorine is going to be NaCl. That's straightforward. Sodium and oxygen, yeah. Sodium is in group 1 with a positive charge. Oxygen has 2 minus. The only way they can bond is Na2O. And I think they're asking that element X has to be 2 atoms, whereas Y needs to... one atom of... oh no, it's the other way around. 1 atom of element X and 2 atoms of element Y. So which is that? 1 atom of X, that's calcium, okay. Calcium chloride, yeah. I thought the question was asking 2 of X and 1 of Y. So it's actually asking 1 atom of element X, 2 atom of element Y. Well, that's straightforward. Calcium chloride. Okay. Your answer is calcium. Which diagram shows the outer electron arrangement in calcium fluoride? To understand this, you need to understand calcium fluoride needs to be what sort of compound? Ionic. It's a metal with a non-metal. So this is out, and we're left with C and D. Okay, let's see what's happening. Now, calcium has a 2+ charge because it loses its electrons and donates it to fluorine and doesn't get anything in return. So these are the inner electrons for calcium and it's lost its outer 2 electrons. ठीक है, I think the diagram's a bit confusing. यहाँ पे art क्यों दिया है मैं? They're the inner electrons of calcium and the outer orbital के 2. One's here, one's here. So C is the correct answer. The only way to differentiate between C and D, I think it's a bit confusing. The best way is to understand calcium will never take, well, there's a 2- charge for one thing, and it'll never take electrons from fluorine. So this is all out. This is completely wrong. It doesn't talk about like how ionic bonding happens. So the answer is C. Okay, I thought I had a highlighter. Why am I talking about that? C. Yay. Alright, let's move on. Part of the periodic table is shown with 4 elements, W, X, Y, Z. These are not the elements with the actual sums. Okay, they're just random. They're just trying to highlight their position. Some pairs of these elements may react to form compounds. Which formulae are correct? W, X, and Y, Z. Well, W and X. That's a group 2 and a group 3. First of all, they probably won't bond because they're both metals. I'm pretty sure. And they should bond not in that ratio. What about Y and Z? Well, it's out anyway. Like you can easily cross out A, but let's confirm Y and Z. Now Y and Z probably won't form that particular in that particular way as well. A 1:1 तो बिल्कुल नहीं होगा. And again, there are also non-metals. So A is completely out. B is WY2. W with Y2. That looks absolutely correct. So kind of like magnesium, which is W is in group 2, so kind of like magnesium, which is in group 2, and Y is in group 17, so that's chlorine. So how they end up bonding is 2 plus and Y is minus, so that's going to give you WY2. That's absolutely correct. And WZ is also correct, where it's W2 plus bonding with Z, which is 2 minus, and that'll give you WZ. So an example for WY2 could be magnesium chloride, right? I think that's exactly what they're talking about, magnesium and, okay, it's not chlorine, it's fluorine, Y, but same thing, right? The groups matter. And I think over here it's definitely magnesium oxide, what they're talking about. So B is correct, but let's rule out C and D as well. Why not? W and Z, which is correct, we've done that. But X and Z? Yeah, no, right? X is in group 3. So the only good example I can think of is aluminum chloride. I think X is aluminum. Yeah, X is definitely aluminum. So X has a charge of 3 plus, Z has a charge of 2 minus. Well, it's not oxygen. It's Z is sulfur, but it's going to behave like oxygen. Okay. And when they end up bonding, it's going to be X2 Z3, because again, these charges kind of go down like that. So C ka XZ is wrong, and we have X2 Z3, which we confirmed, and YZ. YZ, yeah, I'm not too confident either, right? We've already ruled out YZ. So the only viable option that's now left is B. I'm sorry. Alright, which of these is not a redox reaction? Okay, so the best way to identify those are looking at oxidation states. I think this is going to be straightforward. You have calcium carbonate reacting to form calcium and oxygen with carbon dioxide. What is the oxidation number for calcium? It's going to be 2 plus. And this entire ion is one thing, right? This is -2, and I think carbon is +4. Okay, I'm doing the math in my head. You can now, if you have to figure it out, it has some oxidation number, right? It's not 0, so keep that in mind. That's also gonna shine a lot of light. So this is still 2 plus. Oxygen is still -2. Carbon, if you work it out with oxygen being -2, this is going to be +4. None of these elements have a change in their oxidation number, right? So that makes A not a redox reaction, and that's your answer. Let's look at B, C, and D a bit closely. Now, I think a good hint is whenever anything is going from an elemental state and going to is bonding with something else and not itself, is undergoing a redox reaction. How? Well, look at this. The oxidation state when it's in its elemental state is 0. And over here, it'll be not be 0 because it's bonded with something else. We'll have to figure it out. It's probably +2 right now. Okay. It is +2 right now. Oxygen is 0 and it's -2 right now. And we know oxygen does that. So as soon as you see that, anything changing oxidation number, you know it is a redox reaction. Okay? Because oxidation states are changing, hence electrons are being exchanged, hence redox. Okay? C, same example as B. If it's not in like element to compound, at least carbon definitely is. यहाँ पे भी थोड़ा बहुत आगे पीछे हो रहा होगा. Definitely a redox reaction. Over here it's kind of confusing, but wait, iron is being formed in its elemental state. यहाँ पे it's 0. यहाँ पे it's most likely +3. So from +3 it went to 0. It reduced. So something has oxidized it. or something else got oxidized. So you can see carbon being oxidized, iron being reduced very clearly. So D is out as well. And that's like you can rule out B and C very easily. D you can rule out, and you, as it turns out, you don't even need to calculate the numbers for this one, because you can see B, C, and D are clearly redox reactions. But you got to confirm. So, which statement does not describe a redox reaction? Electrons are gained during a reaction. Well, reduction reaction, not redox. So reduction is essentially gain of electrons. Remember Rig, right? So this is describing reduction. Hydrogen is gained during a reaction. Well, hydrogen is gained. If I remember my oil rig correctly, and we're talking about electrons, and we talked about oxygen and hydrogen. So this is clearly loss, and this is gain. This is gain of oxygen, and this is loss, and this is loss of hydrogen and gain of hydrogen. Hydrogen is gained during the reaction. Well, that's also redox. It takes place at the negative electrode during electrolysis. Yeah, okay, electrolysis, we've touched it, not really part of our thing. But negative electrode, even if you have doubts, if it's at the negative electrode, well, negative electrode gives you electrons, though that's a gain in electrons for the cation, right? So this is out as well. This is also true. Oxygen is gained during redox. That should be like a highlighter, like red flare going up. No, oxidation is, gain of oxygen is oxidation. And reduction is loss of oxygen. Oxygen is gained during, so it's not describing a reduction reaction. So D is our answer over here. To successfully identify a redox reaction, you have to follow the oxidation numbers. That's a foolproof way. You're confident in your answer. Let's take a look at A. It's forming AgCl. What is the charge on silver and chlorine? Well, it's bonded to each other. Chlorine is you can be very confident is going to be -1. So silver has to be +1. What was the charge on them before the reaction, positive and negative? Was there a change in oxidation number when the reaction took place? No, there was no change. This is not a redox reaction. The barium ion and the sulfate ion joining, but what's their respective charges on top of them? Well, the barium sulfate will have a 2+ charge bonded to a sulfate with a 2- charge. There's nothing changing again. Same with water. Each hydrogen has a plus charge and each oxygen has, well, there's only one oxygen, but a 2- charge. Nothing is changing. And you see OH here, but OH means what? -2 for oxygen and positive for hydrogen. -2 + 1 is negative. So the charges of each atom aren't really changing. For D, if we take a closer look, is zinc, and it's pretty clear. You don't have to calculate anything. From 0, it's going to 2+, and copper is going from 2+ to 0. Definitely change in numbers, and you can identify this is reduction. Copper is being reduced, and zinc is being oxidized. So D is your redox reaction. ठीक है.